finally, we get mu belongs to the range of values 3.4 minus, oh, I'm sorry, 3.8. 3.8 minus 11.4 is negative 7.6. And then 3.8 plus 11.4 is 15.2. All right, so there's the population mean estimate for the difference of two means. It was between negative 7.6 and 15.2. All right, now to me that's a big confidence interval, and it should be because they were small samples. So, in looking at this data, I've got, if I can find it, there it is. Looking at this data, I'm comparing two classes. And suppose I ask this question, I want to let the winter class represent a sample of all winter classes, and the summer class represent a sample of all summer classes. So the question is, well, this is our best way, based upon the information we have collected, comparing winter versus summer. Now, according to the data, it looks like summer students do better than winter students, according to the data. But then the question is, well, do you have enough data there to really authoritatively say that there is a statistical difference between winter and summer? What's the answer? The answer is no. Why? Because what would be no difference between summer and winter? If in the population of winter classes versus summer classes, if there really was no difference, and by the way, I give pretty much the same exam to all these classes. I just change a few numbers and change the question, but it's basically the same exams for these two classes. There is, what does it mean to be no difference? That means the difference would be 0. Okay, so if that was true in the population, then the population mean difference would be 0. Well, look at our confidence interval. Our confidence interval contains a 0 because it runs from a negative number to a positive number. And so it's possible with 95% confidence that a population mean difference of 0 is inside that confidence interval. So we would say, well, look, we don't have enough data here to show that summer classes perform better than winter classes. We just don't have enough data. And in other words, the difference is not significant enough to make that leap and conclude that summer classes score better than winter classes. All right, so that's, this is statistics. Looking at this, it looks like summer does better, but now we know better. We say, well, okay, that was due to randomness. We don't have enough data to prove it. So, all right, that's comparing the difference between two means. All right, one more problem is comparing the difference between two population percentages. And I'll raise the board and we'll find one more problem to work. I found a problem. It's on page 260, number 45. Number 45, page 260. Let's read it together. In 1989, the National Center for Health Statistics asked youths aged from 12 to 18 years who smoked what brand of cigarettes they bought. Out of 41 African Americans in the study, 61% smoked Newport cigarettes. 5% of the 807 whites smoked Newports. This results in a difference between the two percentages of 61 minus 5 equals 56%. Wow, big difference, isn't it? Now, looking at that, that's pretty big samples, especially the 807 whites. That's a very big sample. And that's an awfully huge difference. So, now the book actually gives the answer on the confidence interval. It says, show that a 95% confidence interval for the difference between the two corresponding population percentages goes from 41% to 71%. Well, I don't know if you're familiar with Newports. I believe it's their marketing strategy to advertise in African American or black neighborhoods. And so if you go through a neighborhood that's predominantly African American, sometimes you'll see Newport cigarettes advertised there. I've seen it myself. I've actually seen it. So for whatever reason, they chose to market to that segment of the population. They don't advertise much in areas that would be predominantly white, and so that's why so few whites smoke Newport, most likely. Well, anyway, there it is. That's, for whatever reason, that's, at least that's what it was in 1989. I think it probably is still that case to some extent today, but I'm not into cigarettes, so I can't tell you for sure. All right, so calculate a 95% confidence interval. Well, let me get some numbers on the board. The sample population percentage for Newports was 61%, and the sample size for Newports was 41. Is that right? Yes. And then for the among the whites, and haven't chosen a very good subscript. They're both smoking Newports, aren't they? So let's call it African American or black. How about we call it black and white? I hope that's okay. Percentage among blacks, 61%. Sample size of blacks in the study was 41. And then the population percentage for among the whites for smoking Newports was 5%, and the sample size for the whites was 807, wasn't it? 807. Okay, there we go. So I got those down. Let's find the formula in the book, and because they're percentages, we're going to need to use the standard normal distribution, the z-scores. So this would be page 250, near the bottom, confidence interval for a difference between two percentages. Okay, well, here is the formula as I would write it.